We shall now go for exercise 10.3. Okay, your NCERT class 12 maths chapter 10 exercise 10.3. Okay, so here there are some things that you need to learn. Scalar product, or we call it as dot product. Scalar product or dot product. Consider that, suppose, or just let's say that A and B are any two vectors. Then the scalar product or dot product of these two vectors will be represented as vector A dot vector B. If A and B are two vectors, then their scalar product or dot product will be represented as vector A dot vector B, and it is defined as magnitude of A times magnitude of B with the cos of the angle in between, where this angle theta is the angle between the two vectors A and B. Suppose if this is your vector A and this is your vector B, then here theta is the angle between the vectors A and B. So this angle is theta. Okay, theta angle between two vectors can be measured only when they are joined tail to tail. Is it okay? If this is your vector A and this is your vector B, then in that case we cannot determine the angle between them. So we have to consider B as the free vector. So B will be shifted from this position to this position, right? Shifting of vectors can be done. So only when the vectors are joined tail to tail, you can find out the angle between them, alright? So for any two vectors A and B, their scalar product or dot product is represented by vector A dot vector B, and this is how it is defined. Vector A dot vector B is defined as magnitude of A times the magnitude of B with a cosine of the angle between them. Using this definition also, we can find out the angle between those two vectors. Suppose you are asked to find the angle between the two vectors, then from the definition itself, your cos theta will be given by vector A dot vector B upon magnitude of A times magnitude of B. So using this definition, or theta will be given by cos inverse vector A dot vector B, okay, vector A dot vector B divided by magnitude of A times magnitude of B. Okay, so the angle between two vectors can be determined. Inverse trigonometric ratios is included in your class 12 syllabus. We will be very soon coming to that as well. Okay, so that is how scalar product or dot product is defined. There are two types of products in vector algebra. One is your scalar product, and one is known as the cross product. Cross product will be dealing on later, so you just remember the dot product. Okay. Dot product of two vectors A and B, denoted by vector A dot vector B. This is how we denote, and it is defined as magnitude of A times magnitude of B with the cosine of the angle between them. Is it okay? So if this is your vector A, this is your vector B, angle between them is theta, then this is how it is defined. And from this dot product, we can also find the angle between those two vectors. Okay? Yes. Next one. Okay, there is an important property for this dot product. distributivity of dot product over addition. That is the first important property. Few properties. Distributivity of dot product over addition means if A, B, and C are any three vectors, then A dot B plus C will be given by what? Vector A dot vector B plus vector A dot vector C. Is it okay? So this is the first property, distributivity of dot product over addition. It holds, okay, this property, distributivity of dot product over addition. The second one, dot product satisfies commutative property. It satisfies commutative property means A dot B is always equal to B dot A. A dot B is always equal to B dot A. The third one, multiplying this dot product with any scalar can be written as A dot lambda B, or we can write this as lambda A dot B. This product also holds if lambda is any scalar. Okay, so these are the few properties that we need to keep in mind. The next one is projection of a vector on a line. Projection of a vector on a line. Suppose L is any directed line. L is just any line, any directed line. And this is your vector AB. L is any directed line. Suppose this is your vector AB. Or let me see, in very simple words, let me say that this is your vector A. Eh? This is your vector A. Then this vector A is making some angle with this L directed line L, right? So the angle made by this vector A with the line should always be measured in anti-clockwise direction. Alright? Now, this vector A, it's making some angle with this directed line L. Then the angle should always be measured in anti-clockwise direction, okay? Yes. Now, you have a directed line L. This is your vector A. And you want to find out the projection of this vector A on line L. On line L. L is your directed line. तो किनेगा करिबो through this terminal point you drop one perpendicular. Okay, suppose this is O, this is your, from this terminal point you drop one perpendicular. Then this OP is also directed towards L, right? So this is O. This OP is directed in the same as that of L, has the same direction as that of L. So I can take this OP to be another vector, say vector P. Or I can take this OP to be another vector, vector B. Because this OP is also a directed line. Itu OP ke ki koribo vector ekta lobi taibe. So let this, okay, let this directed line OP be represented by another vector P, and this vector P is in the same direction to that of L. So let me represent the direction of this line by unit vector P cap. Now, is it okay? So here OP is, vector OP is represented by vector P, or I can say vector B or you can take to be any vectors you like. Okay? And let its direction be represented by p cap. Then the projection of this vector A on L, on this directed line L, is your vector OP. Is it okay? Here vector OP gives the projection of your vector A on line. Projection. Last year, class 11 day, last year you have studied in simple harmonic motion. Okay? Yeah, a particle. Suppose this is the particle. The particle is at P. This is your x-axis, this is your y-axis. Now, the particle is at point P. Okay? You want to find out the projection of this P on x-axis. Then from P you drop one perpendicular to the x-axis. Then this OM is the projection of this P on x-axis. Same. Projection of this vector on this directed line. This vector OP gives you the projection. Okay? Same concept. Alright. In simple harmonic motion, we have studied already this concept. Okay? Let me again say it again. Suppose a particle is in uniform circular motion. This is your x-axis, this is your y-axis, this is your origin. At any instant, suppose the particle is at P, the particle is in uniform circular motion of radius r. At any instant, the particle is at P. And you want to find out the projection of this particle on the x-axis at that time. Then from P you drop one perpendicular to the x-axis. Then this OM gives you the projection of the particle P on the x-axis at that instant. You want to find out the projection on the y-axis. Then from P you drop one perpendicular to the y-axis. This is your N. Then this ON gives you the projection of the particle on the y-axis. Are we getting that? Yeah, same concept. Okay? Yeah. No? So let me say this again. You have a directed line L and you have another vector A. This vector A, it makes some angle theta with the line L when measured in anti-clockwise direction. You want to find out the projection of this vector on this line. This line, this is a directed line. Let unit vector P represent its direction. Okay? So from this terminal point, you drop one perpendicular. So suppose this is your O. This is your, what name do you like? So this OP is also a part of L. So OP is also directed line. Let me denote this OP by directed line OP by vector P. Okay? Then this vector P gives you the projection of this vector A on line. So the projection of any vector on any directed line, in this case, will be given by what? Will be given by, you want to find out the projection of A, right? So A dot, you can write unit vector P. Or you can write the projection of a vector A on this line L will be given by, here vector P represents the projection. So what you can simply do is, you write the scalar product. Write the scalar product of your vector A and vector P divided by the magnitude of P. So this gives you the projection of this vector on your directed line. That's a formula. Okay? Yes. Arabic as well. This is your directed line L. Suppose this is a vector A. This vector A makes some angle theta with this L when measured in anti-clockwise direction. You want to find out the projection of this vector on this line. This line L is a directed line. So let its direction be represented by unit vector p cap. So you drop one perpendicular. Suppose this perpendicular is your OM. Okay. So the projection of this vector A on line L will be denoted by vector OM. Let vector OM be your vector B. Okay. So the projection of this vector A on the directed line L will be given by the scalar product of vector A and B divided by the magnitude of B. Are you getting that? Is it alright? Yes. So these are some of the concepts that you need to know in order to solve this particular exercise. Okay? So shall we start with the first question? What is the first question about? Question number 1.
Find the angle between the two vectors
Okay. Find the angle between the two vectors.
with magnitudes root 3 and 2.
With magnitudes root 3 and 2.
Respectively having a vector A dot B is root 6.
Okay. You need to find out the angle between two vectors A and B whose magnitudes are given now. You want to find out the angle between two vectors A and B, right? Let theta be the angle between the vector A and B. Magnitudes of A and B are given. Magnitude of A is given to be square root of 3. Yeah, it's not root, it's square root. Magnitude of B is given to be 2. Only 2. Also, it is given that the scalar product of A and B is given to be square root of 6. Now, from definition, we know that the scalar product or dot product of any two vectors is given by magnitude of A times magnitude of B with the cos of the angle between them. So, in that case, your scalar product of A and B is given to be square root of 6. Magnitude of A is square root of 3. Magnitude of B is 2 with the cos of the angle in between them, right? So square root of 6 equals to 2 square root of 3 cos of angle theta. Square root of 6 upon 2 times square root of 3 equals to cos theta. Square root of 3 times square root of 2 is square root of 6. So this implies square root of 2 upon 2 is equal to cos theta. Square root of 2 times square root of 2 is 2. So we'll have 1 by square root of 2. We know that cos 45 degree is 1 upon square root of 2, right? So this implies theta will be equal to 45 degree. Pi by 4. Is that alright? So that is how we find out the angle between two vectors according to the given condition. Okay? Any question which is difficult for you? From 1 to 10 you can choose. Easy questions though, it's no point for me doing that. Between 1 to 10, if there is any difficult question, you just let me know. So you're saying about question number 5. You want to show that there are 3 given vectors. Let me denote by A, B, and C. Right? The first part is you want to show that each of them is a unit vector. So you need to find out each of their magnitudes. And each of their magnitudes, if it is equal to 1. Each of their magnitudes, if it is equal to 1, then they are unit vectors. Okay? That is the first thing. Second part, you want to show that they are mutually perpendicular. Let's talk about any two vectors here, A and B. If A and B are perpendicular to each other, then the angle between them will be 90 degree. Angle between them will be 90 degree, correct? In that case, cos of 90 degree will be 0. According to the definition, A dot B will be magnitude of A into magnitude of B with the cos of the angle between them. And if cos 90 is 0, their scalar product will be 0. So in order to show that these three vectors are mutually perpendicular, you need to show that A dot B is 0, you need to show that B dot C is 0, and you need to show that A dot C is also 0. Then the three vectors will be mutually perpendicular.
Projection. A dot B by magnitude of B is 0.
Huh?
Can we do projection of vector?
No, you don't do projection of vector here. Just use the simple concept about the scalar. Okay, there is no, you did a projection. Think about projection for a little bit.
No.
A perpendicular बनाइले तो ये है there is no displacement, no projection, no. Are you following? So you just do it in this order, okay? If you can show that, see, perpendicular means angle to 90 हो angle 90 होइले cos 90 to 0, or cos 90 to 0 होइले their scalar product is 0. So if you can show that the dot product of these vectors, and these two vectors is 0, that means they're mutually perpendicular. That means what we learned here, two vectors are said to be perpendicular if their dot product is 0. Correct? Yes. Search for more. So that is which question? Question number 6. What do we have in question number 6? We need to find out magnitude of A and B. And B, right? If
A plus B
A plus B
dot product
dot
A minus B
A minus B is equal to 8, and also magnitude of A is 8 times magnitude of B. One of the most simplest questions. Let's see. And what do we have? Distributivity of, let's see here, see. Can I write like this? A dot A minus B, correct? Plus B dot A minus B is equal to 8. Now we'll use distributivity of scalar product over subtraction. No? Okay, that minus was too small, so I made it bigger. So this one will vector A into vector A, vector A dot vector A, magnitude of A squared. Now, vector A dot vector A means its magnitude of A squared. Just like A into A is A squared. Okay? Vector A dot vector A gives you magnitude of A squared. Okay? I can give you an example on how it is like this. I can give you an example. Suppose A is I plus J plus K. Very simple. Then A dot A means I plus J plus K dot I plus J plus K, right? Yesterday we have seen I dot I is 1, I dot J 0, I dot K 0. J dot I 0, J dot J will be 1, K dot K will be 1. Now let's find out magnitude of A. Magnitude of A means 1 square plus 1 square plus 1 square, square root of 3. So magnitude of A times magnitude of A will be square root of 3 times square root of 3. So A dot A means magnitude of A square. Alright? Yes. Also, dot product satisfies commutative property. Okay? So A dot B same as B dot A. We'll use that now. Minus A dot B. A dot. Correct? Plus B dot A. B dot A. Minus B dot B. Magnitude of B square is equal to A dot B is always equal to B dot A. So minus A dot B plus B dot A cancel And magnitude of A is 8 times magnitude of B. Magnitude of A is 8 times magnitude of B, and then we have square. Minus magnitude of B square is equal to 8. Is it correct? This is 8, and this is 8 times B. So 64 magnitude of B square minus magnitude of B square is 8. How much will that be? 63 magnitude of B square is equal to 8. What result is this? I hope you are saying the question correctly, okay? So magnitude of B square will be 8 upon 63. So magnitude of B will be square root of 8 upon 63. 8 can be written as 2 square root of 2, 63, 3 square root of 7. And knowing the magnitude of B, using this result, you can find out magnitude of A. So magnitude of A is 8 times magnitude of B. 2 square root of 2 upon 3 square root of 7. That is 16 square root of 2 upon 3 square root of 7. Correct? Next. Feed me more.